Hello everyone and welcome back to the C++ 3D game tutorial series. In this 33rd video tutorial, we will see how to create the components for our entity component-based system. In particular, we will see how to design and implement the component class, how to integrate the components in our entities, and in the end, we will see how to translate, rotate, and scale our entities, making the transform component class. As always, we will face three main parts: requirements, design, and implementation of all the necessary things to create the components for our entity component-based system. Let's start with the requirements. We need a C++ IDE. In this series we use Visual Studio 2019 Community. The target platform is Windows, the target graphics API is DirectX 11, and last but not least, a bit of knowledge of C++ programming language is recommended. Now we can start the design part. The last time we have seen how to create and destroy entities in our game world. Today we will start to create the components. As we have seen in the last tutorial, the components provide specific functionalities to our entities. For example, a mesh component allows to show 2D or 3D objects on the screen. An audio component allows to reproduce sounds, and so on. The problem now is how can we create such components concretely? We could start to add a component class in our entity package. Now, what's the class that needs the components? The entity class. So we will compose our entity class of 0 or more components. Also, for each entity, we should allow to create only one component instance per type. We can do this by adding a map to the entity class, where the key is the ID of the component type and the value is a unique pointer to the component instance. As always, we will see how to implement this composition concretely in the implementation part. What else? Well, we have to create our first concrete component, that is the transform component. The transform component provides, as the name suggests, transform functionalities to the entity and all its components. With transform functionalities, we mean translation, rotation, and scale functionalities. These functionalities, as we have already seen in the previous tutorials, can be achieved through the so-called transform matrix. That means we will manage a transform matrix and the computing of the final combination of translation, rotation, and scale matrices through the transform component. So we will add the usual setter and getter methods for position, rotation, and scale attributes to the transform component class, and we will also provide an update word matrix method in which we will compute the final combination of all the transformations. In the end, since transform component is a core component of the entity, we will create it together with the entity class. If you have questions, doubts, or comments about this topic, don't hesitate to leave them in the comment section of this video or in the Discord server. The link to the Discord server is available in the video description. Also, if you find these tutorials helpful, please consider to support their development on Patreon. Every single contribution makes the difference, regardless the amount. Very well, we have gathered all the necessary information to start the implementation. As first thing, let's create the component class. And as usual, let's add the constructor and destructor methods. Let's remember to add a virtual destructor method. At this point, let's go to the entity class and let's finally compose it with the components. To do that, let's use a map, as we have already done previously for the entities in the world class. We place the ID of the component type as key and a unique pointer to the component as value. Don't forget to add a forward declaration to the component in the prerequisite header file. Now, in order to simplify the work, let's go to the word class and let's copy the create entity templated function. Let's paste it inside our entity class. The way in which we create components inside the entity is practically the same as the one used for the entities in the word class. We have only to rename all the entity references in component. At the end, let's copy and paste the create entity internal method. And let's rename again all the references. Here we have to simply place the ID of the component type and the pointer to the component inside the map. What else? Well, we should store even in the component class the ID of the component type and the reference to the entity that owns it. That's all. Let's try to create a component in the player class through the entity we have already created previously. As usual, let's include the component class in the all header file. Let's test our game. Everything seems to work fine with the final release of the entity after 3 seconds. At this point, we should retrieve in some way the components added to the entity. To do that, let's copy and paste the createComponent function. Let's rename it in getComponent. In order to retrieve a specific component, let's add a further method called getComponentInternal. Through this method, we can simply exploit the ID of the component type retrieved from the template parameter to find our component in the map. In the end, let's call the getComponentInternal method in the getComponentTemplated function. Pay attention, don't remove the static asset as shown in the video. Now we can exploit the getComponent method in the createComponent function in such a way to create a specific type of component if and only if a component of that type hasn't been added yet. Otherwise, let's simply return a null pointer. Very well, let's go to the player class and let's try to get the component of type component from our entity. Let's debug our program. Good, the component is created successfully by checking the presence of other components of the same type. Let's try to retrieve it. And it works! So far, so good. The next step to do is to add the release procedure to the component class. Then let's go to the entity class and let's add a private remove component method. In this case, we have to do nothing but erase the component from the map with the type ID. Let's only call the remove component method from the release method of component class. Very well, let's go to the player class and let's try to release the component created previously. It works! The base component class is finished. Now it's the turn to create the transform component class. Let's add it to the entity package. As first thing, let's inherit from component class. Let's add as usual the constructor and the destructor methods. As we have seen in the introduction, the transform component should manage the transformation of our entities through position, rotation, and scale. So let's add them as Vector 3D attributes. Let's set to scale attribute a default value of 1 for each axis. Let's also add the setter and getter methods for each attribute just added. At this point, we can finally add the core attribute of the component, that is the transform matrix. And let's add a getWordMatrix method in order to provide it externally. The last thing to do is to compute concretely our matrix through a further method called updateWordMatrix. This method does nothing but what we have already done in the previous tutorials. It computes the various types of transform matrices and combines them all together in the final matrix, that is, the word matrix just added as attribute. Before to continue, let's remove the m underscore from the name of the attributes of the math classes in order to be easily usable. Let's remember that the combination of various matrices is performed through multiplication, and that the order of multiplication is important. In this case, we multiply as first matrix the scale matrix, then we multiply the various rotation matrices, and in the end we multiply the translation matrix. Once the update word matrix method is ready, we have to call it each time we set the position, the rotation, and or the scale attributes. That's all. Let's include the transform component inside the all either file. And let's remember to integrate it as the core component of the entity. So, let's store a row pointer to the transform component and let's call the create component method in the constructor. In this way, the transform component is tightly binded with the entity since the beginning. Last but not least, let's retrieve the component through the getTransform method. Let's finally test the transform component in the player class. In particular, let's set a random rotation around the x-axis. As very last thing, let's make a cast of the value returned from the getComponent internal method to the type passed through the template parameter. And it works! That's all for now, folks. Today we have seen how to create the base component class and the transform component. The next time we will see how to make the mesh component in order to show visual objects on the screen. I hope you enjoyed this video. See you soon. Thanks for watching.